Hi, I'm Donald with Steam Bright Supply, and today I want to talk to you a little bit about the science of cleaning. And so I put some notes up here because there's a lot of different parts of it that I want to go over, and I'm sure I'm going to forget some of it, things I want to say, and then I'm going to forget. So anyway, a lot of times people call here and they say, hey, I'm on the market for some piece of equipment. There's 500 different types of machinery to buy for cleaning carpets and upholstery or tile. And where do I get started? How do I know what to get, what to look for? Is it important that I have a heated machine? Is it more important that I have a machine that has more vacuum? You know, what features should they be looking for? They'll talk to people and they say, hey, well, you don't need heat in today's world. We've got chemicals that'll make up for it. And I'm like, that's not really necessarily true. So what I want to talk about a little bit is what's called the cleaning pie. The cleaning pie means that there are 4+ things that are present to get a carpet clean or a surface clean, whether it's tile or carpet or upholstery. And they include things like dwell time, water pressure or agitation, and this agitation quadrant can actually also be mechanical or physical. And we have chemistry and temperature. Now, these walls of the pie, if you could actually picture that they move around. So for example, one methodology is that I have a cleaner and he likes to pre-spray his chemicals down. He takes out a 175 RPM floor machine with a floor brush and he shampoos and scrubs it and gets it all clean. And then he rinses it off with a portable. And he uses cold water to do it. And it looks great when he's done. Well, in his case, because he applied his chemical, so that's a big part of the pie. He had lots of dwell time because it sat on the carpet while he was agitating it. He took his floor machine and had a mechanical machine and he scrubbed it. So these 3 pieces of the pie for him are really large. He had mechanical agitation, dwell time, and chemistry, and he just used a portable with maybe office building cold water and rinsed it off, so he didn't really have any temperature. This is kind of like non-existent, but he made up for it in the other slices of the pie. Maybe you have somebody else who uses a diesel-fired or kerosene or propane-fired heating system, and his temperature is huge. They clean with live steam. And so they pre-spray the carpet, give it some dwell time. They don't do any mechanical agitation, but maybe they have lots of water pressure. They rinse at higher pressures. And this PSI actually is also, I'm going to break this down, is actually a cleaning unit. We're going to talk about cleaning units. I'll give you the formula for that as well. In that particular situation, he doesn't do any mechanical agitation, right? He's just pre-spray, has a real hot machine, uses high pressure, and rinses it off. So this mechanical agitation, his wall is kind of disappeared. He's got a lot of pressure. His temperature is a big part of his pie. And so you can see different cleaning methodologies. The cleaning pie is different based on the kind of equipment you're using or the procedure you're using. But in reality, you actually want to have as much of all the slices of possible to get the best possible clean. So what I want to first is kind of break down this a little bit. For example, PSI or mechanical agitation, like I said, these 2 walls are kind of moving back and forth based on the more pressure you have, that's making this pie bigger, or if you're adding physical mechanical. And physical and mechanical agitation can be different kinds. Like I could have maybe one technician, he likes to take a Grandi Groomer, which is this on a wooden stick, and he pre-sprays and he agitates the carpet with a Grandi Groomer. Somebody else might use a Grandi brush, which is more like bristles, and they agitate and then rinse. Maybe you have somebody else who likes to agitate with a 175 RPM floor machine and they put a full face brush on and agitate Now, those are examples. Like I have in the mechanical agitation, that's actually can be broken down into both vertical agitation and horizontal agitation. So if I'm going across the face fibers, that's horizontal agitation. Like this is spinning across the surface, right? I can also have vertical agitation where my agitation is down to the backing and back up. So a counter-rotating brush machine would be a machine that spins these brushes in opposite directions, and that goes down to the backing and flips up the fibers. So some reasons why you might change what you're doing, for example, a Grandi groomer is specifically for twisted filament. So if I look at the fibers coming up out of the backing and they have a twist to it coming up, this is the correct type of agitation to use if I'm going to physically do it myself. A Grandi brush is specifically for straight filament. If you look at how a wool fibered Oriental rug, how do the fibers come out of the back? They just stand straight up. A Grandi brush would be used for an Oriental rug. If I use a Grandi groomer on an Oriental rug, I will pretty much ruin it. Some people will take things like a bonnet, and a bonnet can be done in several different ways. This right here is referred to as a bonnet, and they can be made out of different materials. They can be made out of cotton, they can be made out of cotton and polyester, and they can be made out of polypropylene. Now this particular bonnet here is a cotton polyester material on the white and polypropylene on the agitation stripes. You can also buy what's called a dirt napper or a bonnet lock, I'm trying to think of the name of it, which it actually incorporates like a floor machine brush. Like if you could picture just using these outer row of bristles on the outside and then trim these inside ones short and then get a bonnet that fits in the middle, so that when you're agitating it, you have both the bristles contacting the outside and then the bonnet hopefully absorbing the dirt on the inside. And the idea or principle of using a bonnet is kind of like if I sprayed soap and water on your car and then took a terry cloth towel and went out there and just toweled it off, the towel would get dirty, right? And it would make the car look cleaner. It isn't necessarily the perfect way to clean, but it does improve cleaning results, especially if you're going to use some form of rinsing or hot water extraction afterwards. These full-faced brush are also available in what's called a glide brush. And a glide brush is where half of the bristles have been removed and a stainless steel dome is inserted in the middle that you can adjust the height of, and that dome supports the weight of the floor machine, and they usually use a slightly smaller denier. Now the denier refers to the thickness of each hair coming out of it. So if I have a lot of times a brush for carpet, for residential, is going to be like a 0.22 denier, while a commercial carpet is going to be typically like a 28 denier. And then you can also have different fiber types, like you can have nylon bristles and polypropylene bristles. This is a combination of both. It has nylon in the middle and polypropylene on the outside. The nylon offers a little bit more prevention of the bristles laying over flat while you're using it. Makes it last a lot longer. The polypropylene brushes typically are about a third less money, but they also don't last as long. Another way to agitate, not too commonly used, but is to use a white or champagne or even a red pad, and this would be for commercial carpets. So they would use a pad driver, which is typically like a like a brush, but it's got real short trim on it that's stiff bristles. And that's going to hold this pad. And again, they would well lubricate the commercial carpet and then use the pad to spin over it to have a form of agitation. Now, this being that it's plastic doesn't absorb a lot of dirt, but you could accidentally end up with some dirt that ends up inside of it. And naturally, you could use both sides of it like the Bonnet. We have found in side-by-side comparison, if you agitate horizontally compared to vertically, where it's going down to the back and up again, the vertical agitation wins. Certainly it's better to do some form of agitation if you can, but in side-by-side comparison, vertical, like this would be like if you look on our website, and I'll put some links on there, a counter rotating brush machine would run this type of device, like a CRB, which is the acronym means counter rotating brush. CRB 17, for example, is what this is from. So you can have water pressure in here. A lot of times some people will use a machine that's only 120 psi. Well, other times they might use 500 psi to rinse carpets. I have known that some cleaners will use 600 or 700 psi. Now, the problem is when you get past about 650, you do run into what's called pressure marking the carpet. And that is where the water jets has so much force coming out that it's actually causing the untwisted, the twisted filament to become untwisted, and it leaves streaks in the carpet that is almost impossible to fix. So don't get too zealous and thinking more pressure is better. Typically, most people, to be safe, leave their water pressure at 500 psi or less for carpet cleaning. And the idea is that the carpet's already clean and you're just using it to rinse. So if I've already pre-sprayed and I've already agitated the carpet, it's already clean, I'm just rinsing it off. So in the water pressure part of it, the actual formula is cleaning unit, which is this one up here. Okay, maximum PSI or pounds per square inch times maximum gallons per minute equals speed. So pounds per square inch is a form of agitation when you're multiplying it by gallons per minute. The more cleaning units I have, the faster I can rinse a carpet. So can I get a carpet clean at 100 psi? Yes. If my pump is only rated for 1 gallon a minute and at 100 psi, then when I multiply that, 1 times 100 times 1 equal, I have a 100 cleaning unit speed. Maybe I have another machine, and let's say it cleans at 500 psi and it offers 2 gallons a minute. So if I take that formula of 500 times 2 gallons a minute, that is a 1,000 cleaning unit speed. That 1,000 cleaning unit speed can actually rinse the carpet 10 times faster than the guy who only had a 100 cleaning unit speed. And that works with all portables or truck mounts. Now you can also change the size of the orifices of your wand. So I've had people, they misunderstand, well, is a 2-jet wand better, or a 1-jet wand better, or a 4-jet wand better? Well, it kind of depends on what machine's pushing it, because some machines don't produce enough back pressure to maintain a high use pressure. So the pressure is actually, there's 2 forms of pressure. There is standby pressure and actual use pressure. So standby pressure would be, hey, what does the gauge on my machine read when I'm not using it? It's standby, right? What is my standby pressure? My use pressure is what is it actually cleaning at when I squeeze the trigger? How much pressure is actually hitting the surface? That's actually a more accurate way of determining your cleaning speed, right? But if I have a machine that is, so I'm going to kind of break this down again. In the category of portables, there are suction-fed portables and there are pressure-fed portables. So the difference, if I have a tank, and let's say it's just a tank of water hooked to a portable, and then the pump has got to get the water and then push it to the wand. Oh my. Push it to my guy cleaning the carpets. Well, this is an example of suction fed, because when the pump is turned on and you're squeezing the trigger, it's got to go get the water from the tank. A pressure fed example is a machine that has 75 psi from the building that's being force fed into the pump. And when he squeezes the trigger, the pump doesn't have to go get the water, it's being force fed. You will notice a substantial difference in their use pressure on a pressure fed system. It also, when you have water sitting in here, it's typically cooling down. So if I let's say I had 118 degree hot tap water and it was just sitting in here, it may take 15, 20 minutes before those water molecules get picked up from the pump and pushed down to the hose. By then, this is cooled down 10 degrees. So an exact comparison of somebody using a pressure fed system versus a suction fed system, typically we find the pumps last longer on pressure fed. When you suction feed a pump, the seal kits wear out sooner. When you pressure feed them, they last longer. In fact, it's almost 6 times longer when you pressure feed a pump seals. The temperature is usually 10 to 15 degrees hotter when you pressure feed it, because if it goes right from the building water heater to the pump and then to the wand, it doesn't have time to cool down. It's never sitting in a tank. So that helps your cleaning unit speed, because I have my use pressures higher, and a lot of times if you're pressure feeding it, your total gallons per minute is higher as well. So the other part of this, so we have our cleaning unit, which is changing where that wall is, right, our PSI and gallons per minute, whether we're going to incorporate physical or mechanical agitation. And that can also be done with a rotary power wand. So in today's market, we have the Rotovac 360i, which is a 12-inch tool. We have the Rotovac 360 XL, which is a 15-inch tool. We have the Mytee 15-inch T-Rex, and then we have the Mytee T-Rex Junior, which is a 12. And then we have the HydroMaster 17-inch. So the RX20 is the name of it on our website, the RX20, but it's actually a 17-inch rotary power wand. And what those wands do is they apply the rinse or the water while they spin around, and they've got the shoes, the vacuum shoes, there picking it up. So you may have multiple passes with lots of gallons per minute. In fact, on average, a rotary power wand uses 100% more gallons per minute than a traditional fixed jet system. So their cleaning unit number is dramatically improved, plus they're making their agitation, their mechanical part of their pie, becomes much larger. The other thing that I want to talk about is temperature. So you can see here, temperature is 1/4 of the cleaning pie. And if you refer back to your 7th grade science class, and we think about, well, what are we rinsing with? We're rinsing with water, or H2O, right? And water can be in different vibrations. So I have ice, which is a solid. I can have water, which is a liquid. I can have steam, which is a vapor. How does the water molecule of H2O transition between being a solid, a liquid, or a vapor? It's done through water molecule vibration. So I know this is really hard to see because it's small print, but I put down here 118 degrees Fahrenheit. And if I raise the temperature to 136 degrees Fahrenheit, my water molecule vibration exponentially doubles every 18 degrees. So here, if let's say I have, this is an electric heater out of a Mytee, and if I am using a 2000 watt heater, a lot of times my temperature rise based on my gallons per minute and the pressure I'm using and how fast the water flows through the heater, I can get a 20-degree rise up and above whatever I'm feeding it. So if I have my machine here, and let's say I put 118 degrees, but then it cooled down 10 degrees because I'm suction feeding it, I might only be starting out with 108. I lost 10 degrees. But then it went through the pump and through my inline heater, so I boosted it up another 20. Well, when I boosted it 20, I doubled my water molecule vibration to what it would have been if I hadn't used a heater. So if I boost it again, let's say I've had people where they stack their heaters. They have an internal heater under the hood of the portable, then they buy another heater outside the portable to run it through again. That may add another 25 degrees. They could easily be cleaning at 154 degrees Fahrenheit, actual temperature. Well, that means the guy cleaning at 154 is twice as effective in his water molecule vibration as someone cleaning at 136, and 400% more effective than someone cleaning at 118. So again, somebody cleaning with a truck mount, most truck mounts actually will clean, if they're a heat exchanger machine, around 172 degrees. So, but they're starting off, instead of starting at 118, they're starting at 65, which is the cold tap water coming out of the garden hose. So they're adding about 110, 115 degrees. Usually their pressure is higher, their use pressure is higher, and their gallons per minute is higher. They got larger nozzles on their wand, so that's making their cleaning unit number higher, and they're still able to maintain 172 degrees, which is 800 times or 800 times more water molecule vibration than someone cleaning with hot tap water, and still twice as more effective in your water molecule vibration than someone cleaning at 154. So, and again, I put the numbers on here. 190 is 16 times more water molecule vibration. 208, 32 times more water molecule vibration, someone cleaning with hot tap water. Cleaning at 226 is 64 times more water molecule vibration. Now, what ends up happening when you end up past 212, most of the machines that are like diesel fired, kerosene fired, they're going to have what's called a safety pop-off valve. If you look back at what made the trains or the locomotives go down the track 150 years ago, they used water, and then they would throw coal or wood into the burner and turn every cubic inch of water. When it flashes the steam, makes 10,000 cubic inches of vapor. Because of that immense explosion in size, they would use that to drive the pistons and push the train down the track. So if you heat water up too fast, you can have an expansion, and a lot of times you'll notice on some of the brands, on like the Clean Storm Volcano hot box heaters, they have a 550 psi safety pop-off valve, because that way if you accidentally flash past steam, it just dumps any water pressure past 500 psi back into the sink or your fresh water tank of your portable. Some of the machines actually will have that. If they actually have a heater installed under the hood, coming off the hot side of the heater, there'll be a T-fitting and then another little safety valve there, and it's monitoring that. If it goes past 500, it dumps the water back to the fresh water tank. And again, that's because these thermostats that control this temperature can break. I did also want to point out, when you have different heating systems, like there is the kerosene and propane ones, those are flow controlled units. In other words, they don't heat the water with the flame. They typically can be 200 to 350,000 BTUs of heat. So temperature here, this is actually meaning BTUs of heat. And there is a way to actually calculate the British thermal units or BTUs of a portable or a truck mount. Most truck mounts have about 55,000 BTUs of heat. per heat exchanger. So if they have an oil to water heat exchanger, that's $55,000. If they're using the engine exhaust, that's another $55,000. If you're using the blower exhaust, that can be another $55,000. If it's using a radiator, that can be another $55,000. Those are just kind of general, but depending on how many different heat exchangers they can have $200,000. But typically, someone who's using a fuel-fired system like a kerosene or propane or a diesel heater is going to have way more heat than a truck mount would, even if they have multiple heat exchangers. Because it's not uncommon for a pressure washer that's using diesel to be in the 300,000 BTU range. So they have no problem getting to whatever temperature, even if you're laying on the trigger full time. So even at 350,000 BTUs, you could have two people using two tile spinners laying on the trigger full time using 4 or 5 gallons a minute. The heater doesn't care. It's producing so much heat, it doesn't have any problem keeping up. So those kind of systems are super hot. Or if you had a portable and you were trying to clean tile and grout, to begin with, none of the electric heaters are designed for more than 500 psi. These stainless steel outer cores are pressure tested at 1500 psi before they're put in the machine, but that doesn't mean it's okay to use it at 1500 psi. You're not supposed to go past 500. So that's another kind of thing that I have people to go, hey, can I buy a tile cleaning machine with heat? And I was like, well, with electric heat, no, because unless you're going to clean at 500 psi, well, then you can. And the only tile cleaning wand that can clean tile at 500 psi is called a Rhino, and it only cleans 3 inches at a time, but it works really, really well. So if you want to use a carpet cleaning machine to clean tile and grout at 500, it definitely does it really, really well. And we have some videos on our website showing that, and I'll put the links. So another thing that I did want to point out on the electric heaters, there are basically two different kinds. You're going to see screw-in elements where the heating system is actually in the water, and then you're going to see this kind where the heating rod just heats the casing. So most of the time, most of the factories prefer this type of heater because it heats the casing, which means if you accidentally run it dry, you let your tank run out of water and you're not paying attention, it doesn't break anything. If you have the kind of heater that the heating element screws into the water and the heating element is in the water, when you have it fall out of the water, it usually will break the rod. That's true with bucket heaters. So like if you look on our website for the word bucket heater, you'll see those typically people put the bucket heater in a 5-gallon bucket and plug it in. And if you accidentally leave the heater energized and lift it out of the water, you can break it. I've had people say, well, they take their heating bucket heater and lay it in the fresh water tank, which is a huge no-no, because when the machine runs out of water, it breaks the heater. The pump seals are only rated for 140 degrees, and as the water level gets lower and lower and lower, a lot of times the water is going to go over 140 and it's going to ruin the seals of the pump. So don't do that. It's like you can break the heater and the pump and the regulator all at the same time because you stuck the bucket heater in the fresh water tank. The only other company that I know that uses like screw-in heating elements, EDIC does it. So the EDIC Galaxy series, they use screw-in heating elements, and those elements are actually in the water, so you cannot run those dry. Another thing that I wanted to point out, and I don't know how to tell you this, but factories have a tendency to fudge numbers on their ads to try to get people to buy their equipment over somebody else's. To give an example, we would see some machines say, hey, it's a 2,000 watt heating system under the hood, and we put a amp meter on it, And the formula for watts is amps times volts equal watts. Or I could take the other way around and say, well, if I'm plugged into 120 volts and an item is only pulling 15 amps, well, then I know I can use that formula to figure out the missing number, and it's only 1750 watts. So we would see that on machines that are clearly advertised. The factory says, hey, it's got a 2,000 watt heater under the hood, and people bring the machine in for repair, and we pull out the heating system, and it's stamped. They're always stamped on the side. It says it's 1750 watts, and I'm like, why do they think that's okay to do? We see companies lie about vacuum units, and I haven't talked about that yet. A vacuum unit is almost like the fifth part of the pie that's not typically taught in the classroom. So we have dwell time, agitation chemistry, and water temperature, or BTUs. The fifth part of this, that actually part of your cleaning process, is actually called a vacuum unit. And the formula for a vacuum unit is maximum inches of water lift at 0 CFM times maximum CFM at 0 inches of lift. And a lot of times people go, say what? So I'll kind of break that down. Maximum inches of lift, that means at sea level. Inches of lift means I'm at the ocean, I have a swimming pool, I have a clear 1 inch inside diameter pipe sticking in the swimming pool, and I go up to the balcony and I put my vacuum hose on the end of that, and I turn it on, and I want to see it pick up 1 inch solid column water, which has got weight to it. It's heavy because it's 1 inch in diameter and water's real heavy. How high can it pick up above sea level when it reaches 0 CFM? Because when it finally quits moving, I got no airflow. I have 0 CFM. What is the inches above sea level at 0 CFM? So that is the maximum inches of lift at 0 CFM times maximum CFM at 0 inches of lift. The other part of that, I take my hose off. How many boxes of air? 12 by 12 by 12. That's 1 cubic foot. Leave the machine at 0 inches of lift. So if I have unrestricted, how much ability does the machine have to displace the air through the machine? It goes in and back out. Maximum CFM, cubic feet per minute, box of air, 12 by 12 by 12. Leave the machine at 0 inches of lift. If I multiply maximum inches of lift at 0 CFM times maximum CFM at 0 inches of lift equal vacuum unit. A vacuum unit tells you the amount of footage that you can have and still get a carpet dry. Naturally, the more vacuum units I have, the more mud it picks out of the job site. So I'm going to give you an example. Let's say you have the average house you're doing uses 35 gallons of water. And if I was able to drain that all at the exact same time, and I went, okay, I used 35 gallons of water, but I drained out 25 gallons of mud. Looks like motor oil when I drain the machine. Where's the 10 gallons? Well, the 10 gallons you left in the house, was it clean water or dirty water? And a lot of times people go, well, I was using clean water to rinse. That was clean water I left at the house. And I go, no, think about it. I'm using my wand. My wand is coming over the carpet. It doesn't go, ooh, you're a dirty water molecule, jump in my waste tank. You're a clean water molecule, stay behind and evaporate. The wand doesn't differentiate like that. It's like whatever's on the floor, it picks up. So if you leave 10 gallons of water, the 10 gallons you left in the house is just as muddy and nasty as what you just took out of your tank. So when I have a system, I'm trying to calculate, well, how do I want to develop the best cleaning pie or methodology for my system? I want more vacuum units. The more vacuum units I have, the longer the hose I can have, and the better job I'm going to do of getting the dirt and mud out of the carpet. Now, here's the thing. As cleaners, we don't use either one of these. And what I mean by that is, if, let's say I'm using 100 feet of hose and my wand is got a 1/4 inch lip and I'm using a 12 or 14 inch wide wand and it's sitting on fabric that's damp. Well, that's not a perfect seal. It is not like a perfect occlusion. Like when I'm taking my inches of water lift, a lot of times if you take a vacuum gauge, right, it's actually sealing off the air. It's moving it all the way to 0 CFM to take that reading on that gauge. Well, when I'm cleaning the carpet, it's not at maximum inches of lift. It's not at maximum CFM. It's like if I stuck the gauge in the middle of the hose, what is it doing? It might be doing half, right? It's not doing either one of those. It's doing both just a little bit because it's half restricted. It's the hose distance, which is creating some drag, with the lip of the wand sitting on damp fabric, which is not a perfect seal. So what ends up happening, I have a lot of people misunderstand, what does a vacuum booster do? If I use either, and you'll see on our website, we have machine mount vacuum boosters, we have hose mount vacuum boosters, we have exhaust mount vacuum boosters. If you're using a vacuum booster, typically what they do is they change the CFM. They don't change the inches of lift. I have people, they go, hey, I bought a vacuum booster and it still reads the same inches of lift. And I was like, yeah, well, what'd you think it would do? It doesn't do anything to that. It is primarily changes your CFM. And with the CFM, like if let's say I have a system and it's normally was 200 CFM, and when I put the wand on the carpet with 100 feet of hose, let's say I'm restricting it 50%, okay, now only 100 CFM is making it through the hose. But if I added a vacuum booster and I moved it up to 300 or 400 CFM, now when I put my vacuum hose down and my wand down on the floor and it restricted it by half, all of a sudden that 400 CFM is 200 CFM in the hose. It is still changing my actual vacuum units, my use vacuum units, because this is really standby vacuum units, like theoretical. Our actual use vacuum units is always different than our standby vacuum units. And naturally, our use vacuum units is really the number that's making the difference. If you're using a vacuum booster, it changes your use vacuum units and changes your standby, but it's still a means of explaining or comparing equipment or your methodology of what you're cleaning with. So another thing that we want to talk about is chemistry. How does chemistry, I've had people say, hey, with today's chemicals, I don't need a lot of temperature, dwell time, or water pressure, and the chemicals can make a difference. So how can you change that? One is understanding the pH. Now, this chart here, I realize this is kind of hard to read, but the pH scale is from 0 to 14, and denatured water, which is 7, is in the middle. And this is anything coming down from 0 to under 7 is an acid, and above 7 is an alkaline or a base. And it is in a series of 10. So what I mean by that is, if I have the idea behind the pH is that whatever your stain is or your contamination, you typically want to do the opposite. So you will notice that if dirt, which has a pH typically about 6, people typically are going to want to come over to the other side and use an 8 or a 9, in some cases even a 10. So what ends up happening here is I drew a 1-inch mark above the line. I said 6 is 10 times more acid than 7, and 8 is 10 times more alkaline than 7. 9 is 10 times more alkaline than 8. 10 is 10 times more alkaline than 9. So what I tried to do, because a lot of times when if you go back and look at your chemistry book in high school, you'll see that they had this chart. I mean, it's like they use a picture like this, right? And it's like showing how it goes up. As you get further away from 7, it goes up. And I go, but that's really very unrealistic, because I put some numbers down on here. If this is a 1-inch mark and it's an 8, number 9 is a 10-inch mark. Well, that means over here, pH 10 is a 100-inch mark, or 8.33 feet. Well, all of a sudden, my board isn't tall enough. It ended up here. This is a 3-foot board, but it kept going way past into the second floor of the building. So when I'm at a pH 11, I'm at 1,000 inches, or 83.33 feet. When I'm using a pH 12, that would be example of 10,000 inches, or 833.33 feet. pH 13, 100,000 inches, or 8,333 feet. pH 14 is 1,000,000 inches, or 83,333 feet, or 15.78 miles. So the stronger you get your pH, the more you're making this pie bigger, but it's not necessarily that more is better. And what I mean by that is there are guidelines. If you're cleaning a carpet that is under 5 years of age, in other words, it's got a warranty, then you can't just do whatever you want. And the interesting thing, for the 20 years that I was on a truck and I cleaned 20 million square feet of carpet, I used to have a lot of people say, "Hey, Donald, I've been cleaning carpets for 5 years. I want to come work for you." And I would be like, "Okay, can you tell me some things that are not okay to do that will void the warranty on a brand new carpet?" And most of them are like, "I don't know. Never thought about it." And I'm like, "Well, you can't just do whatever you want." One is most carpet mills say you can't go over a pH 10, or that'll void the warranty. So the other is that most of them say you can't use cationic surfactants. I didn't put any of that information up here, but a cationic surfactant means a surfactant carries a positive electrical charge. Some examples of cationic surfactants would be defoamer, or silicone, anti-static liquids, and quaternary ammonium chloride, which is probably one of the most common disinfectants used by carpet cleaners. I have carpet cleaners all the time that use Microban or Metaclean, which is quaternary ammonium chloride, and they think it's okay to just use it as an additive. Well, the interesting thing about quaternary ammonium chloride is it doesn't have an adverse reaction when you add chemicals to it, unlike glutaraldehydes and other types of disinfectants, which are not okay to add chemicals to them. You have to be used as the label says in the bottle. So you want to make sure you read your bottle labels accurately, but if you're doing carpets that are under warranty, make sure you don't go over the pH of 10, you don't use cationic surfactants, and you like defoamers or quats, things like that, anti-static sprays. So another thing that can change your chemistry, how do I change my size of the pie, make this bigger? One would be oxidizers. Now, oxidizers, if you think about, what is that? Well, normal water is H2O2, or 2 atoms of hydrogen, 2 atoms of oxygen. I'm sorry, that's hydrogen peroxide. Water is H2O, so it has 2 atoms of hydrogen and 1 of oxygen. But when you add an extra oxygen to it, like hydrogen peroxide, it's adding an extra oxygen. There are other oxidizers that can be powdered formula. So that can be one thing, is you could add hydrogen peroxide. Very expensive to do, but you could add it, incorporate it as part of your cleaning process. The other is that you could use sodium percarbonate peroxyhydrate. Now, sodium percarbonate peroxyhydrate is an active ingredient in many different cleaners. This is an example one. OSR by Pro's Choice has that chemical in it. It's about 50% that chemical. If you add that as an additive, what it does is it makes it more effective on organic contaminants. Organic would be things that man did not make. Like man-made contaminants would be like dye, Kool-Aid, things like, hairspray, chemicals that may have entered the carpet that were man-made. Organic would be like juice, blood, urine. So if I have something, an organic contaminant that originated from a plant or a body, coffee, tea, mustard, juice, wine, blood, grass stains, typically oxidizers improve the effectiveness of getting those removed. So the other way to change your chemistry, besides adding more oxygen in the water through sodium percarbonate or hydrogen peroxide, is to use some type of solvent. Now, water is the universal solvent, but I mean like hydrocarbon solvent. This is an example. A lot of times I was going to bring in the Shazam Kryptonium is made out of monobutyl ether EB, and that butyl is a solvent, and this product here is energy, and energy uses some delaminine or primary amyl acetate. This is the formula for primary amyl acetate. The delaminine is a hydrocarbon solvent that comes out of orange peels. So if they use like a orange or lemon terpene, or if they use the primary amyl acetate is a terpene that's extracted from banana peels or apples. Usually they use a blend of apples and bananas, and they actually make a solvent or an oil out of it. And they blend it with surfactants so that when you add this to your cleaning compound, to your pre-spray, it works on not just the water-based side of stuff, but the oil-based side of contaminants. The other is the use of optical brighteners, and I did not bring one out here, but optical brighteners is, if you look at, again, going back to your 7th grade science class, if you look at what makes up a white light, or the colors of the rainbow, right? You have all the colors of the rainbow that you can separate with a prism. You might remember doing that in 7th grade science class. They have found that how you perceive the carpet, if you reflect the violet spectrum of light to your eye, you perceive it to be cleaner than it actually is. So optical brighteners use that. They were very common in the late 70s and early 80s, because in the 70s primarily people just used a rotary shampoo, and then when we got into the 80s we changed to hot water extraction. And because a lot of times people weren't rinsing the carpet in the 70s, they were just using a shampoo, they had to put a lot of optical brighteners in it to make it look cleaner. So it just looked cleaner because of how it reflected the light. Today you will find that in, and I'll put the link on our website, it's called Enhancer, and it is made by Certified, or nil odor certified enhancer. It changes how you perceive how the carpet looks. So you can change the pH, you can change the oxygen, you can add solvents, you can add brighteners. And so that's how you can change your chemistry. Now, one of the things that I did want to point out about that is a lot of times people think it's okay, hey, can I just put the chemicals in my tank? And well, you could, but then you lose your dwell time. If I pre-spray it first, it might be sitting on the carpet 15 or 20 minutes, which is making this dwell time really big. If I put it in my machine and then I run it through the pump, it was only on the carpet 1 second before my vacuum came and picked it up. There's such a huge difference between 15 or 20 minutes versus 1 or 2 seconds sitting on there. So the other problem is that people that do this, when they're done with their job, they stick their vacuum hose in their tank and they suck out the water and then they go park it. Well, guess what's in the pump? Degreasers, different chemicals that get the carpet clean. And you know what degreasers do? They eat grease, which is what's rubber seals. The plunger and the pump is made out of rubber. And these chemicals will deteriorate the seals in the pump head. So if you ever put the chemical in the tank, you need to make sure that you fill the tank up with a little bit of water and sit there and run it for a while to displace all the chemicals out of the pump. So when you turn it off, what's parked in here 24/7 when you're not using it is just water. The other part of that, as you change the pH, as you get higher in your pH, it displaces the minerals out of the water and puts it on the lining of the heaters. So if you use a heated machine, and this is no different than if you own a coffee maker and you go, well, eventually I got to run some vinegar through my coffee maker because I got to descale it, because when you heat the water up, it causes the minerals to separate out of the water. Well, that separation effect happens faster if I raise the pH. So the higher I raise the pH, the faster I separate the minerals and gunk up my heater. Now, if you have a kerosene, diesel, propane heater and you never descale it, how long does it take before it has a heart attack and water won't pass through it? Typically, I have found some people that can ruin their heater in 6 months. You never descale it or run it. The descaling products are typically like, they're down here at a pH of 3. So, and when they're run through the machine, they break up those minerals and allow them to flow out. Now, if you use a formulated rinse aid as part of your everyday rinsing of the carpet, what that does, so let's say my pH of my dirt is 6, and I'm gonna use a pH of 9, because if I used 8, it might get some of it out, right? But I wanna aggressively get it clean. So I'm gonna come up here to a 9. So I'm pre-spraying up here at 10 inches, and I'm gonna rinse with water, which is over here. Well, guess what's left? My carpet ends up being somewhere like an 8. That's that drew line there to represent, here's my dirt, here's my pH. I came back and I rinsed with 7. So it's gonna be somewhere between there, it's around 8. So the only way to combat that is if I pre-spray and scrub with a 9, I actually want to lower my pH with a rinse aid. But you only put a little bit. So rinse aid, you only use like 1 or 2 ounces per 10 gallons. I mean, 1 gallon, actually 1 ounce per 10 gallons is plenty. It doesn't take much. And that'll lower the pH down here. So when you rinse, it will actually leave it closer to 7. And when you do that, it will leave it much softer and prevents wicking. So depending on the fiber type, and I'm going to do another video how to determine the fiber type, whether I'm rinsing polyester, nylon, jute, silk, wool, rayon, the different fibers that you're going to run across, how to determine what you're actually rinsing. And I'm going to just kind of tell you the reason why I think that's so important. If you took your car to the auto mechanic and you drove it over there, you say, come look at my car, the first thing you ask him is, what kind of car is this? And he's looking at it and go, I don't know. Might be a Toyota, might be a Ford, might be a Hyundai. I don't have any idea. And he's a professional. Yet carpet cleaners do that all the time. You go to their house and they say, well, what kind of carpet is that? You're going to clean it. I hired you to clean it. And you're like, I don't know. Might be nylon, might be polyester, might be a blend. You're clueless. You don't even have any idea what is okay to do on what fibers. They hired you to clean it. So just like that, you haven't instilled, the auto mechanic hasn't instilled any confidence in you, you're not going to instill it in your customers till you kind of learn some of the science behind what it is that you're doing and why you're doing it. So I'm going to look at some of my notes. Oh, I did forget to mention on Here, there are different kinds of heaters. So we did mention that you can have a submersible heater. Some companies actually do mount heaters under the hood. Usually they're after the pump. That would be like this style. You can also buy some portables where the heating element is actually in the fresh water tank, but you need to be careful if you end up with that style. You can't let it run out of water naturally. Cleanright makes some machines like that. They're kind of rare, but they do it still in production. One of the other kinds of heat exchangers that you would see on a portable, there was, so you have the screw-in heaters, you have the rod style heaters, but there's also a heat exchange heater and a portable. The Complete Heat, Goliath Complete Heat, actually uses the exhaust of the vacuum motors to heat the water. That's a 14,000 BTU heater, which is actually the same as 2 electric heaters. It's really impressive. By the way, a 2,000 watt heater is right at 6,000 BTUs. So I have some people, they tell me, they go, well, why can't I hook up my 2,000 watt heater to a garden hose and think it's going to clean its steam? Well, it's not enough BTUs. If I'm using a system that's got 200,000, to 300,000 BTUs, that's nowhere near 6,000 BTUs. It's just a huge window to think that it's okay to put cold water in here and that this is going to come out steam. This is not going to happen. Just not enough energy in the water. The other kind of heat exchanger, so on the truck mounts, we talked about the radiator, we talked about the oil to water, the exhaust of the vacuum. Also on portables, you can get the exhaust of the vacuum, and then you can also talk about the exhaust of the engine. The other one is ambient heaters. There are, DeConey Corporation was making the Black Max series of portables. They just discontinued them this year, but they would actually put copper coils under the hood of the portable. And the idea is kind of like, hey, if I took my car and I closed the hood and drove around, and then I opened the hood and stuck my hand under the hood, well, it's hot under the hood, right? Just the normal ambient heat. And they were absorbing some of that. So the Black Max series had those. If you might still be able to buy them on eBay because it's a discontinued model. The other, in the truck mount world, the only truck mount that I saw that was doing that was the Hydromaster Spitfire. They actually had a little radiator that was out in the open, and because it's an air-cooled engine, they were using an air-cooled Briggs, and as the air went over the engine and blew out the back end, they had a little radiator there to pick up some of the hot air that blew across the cylinders. So that was the only other type of heat exchanger that I've seen. Okay, so one other thing that I want to talk about is performance unit. So with the formula for performance unit is a cleaning unit, which we talked about, a vacuum unit, which we talked about, and the BTUs we talked about. So that is a performance unit. Every single truck mount, every single portable has a performance number. And it's using, how much cleaning unit, which is your water pressure in gallons, you multiplied together, right? Which means speed. That's this one here. Talk to maximum pounds per square inch times maximum gallons per minute equals speed. That's your cleaning unit. All portables and truck mounts have a cleaning unit number. All of portables and truck mounts have a vacuum unit number, which again, your vacuum unit number is this formula, maximum inches of lift times at 0 CFM times maximum CFM at 0 inches of lift. And all systems have a BTU number, whether it's a portable with 6,000 BTUs or a Goliath Complete Heat, which is about 21,000 BTUs, or maybe a truck mount with 150,000 BTUs, or whether you're using a kerosene or diesel heating system, it could be 300,000 BTUs. Every system has a BTU number. So if you add your cleaning unit number to your vacuum unit number, your BTU number, you get a performance unit. The performance unit, and I have on our forum, so just people always ask questions that are already clearly posted on our website. On the right-hand side of every single web page, there is a street sign. It says, have lots of questions and know where to ask? Click here. And you go ask that website whatever question you want. And it will go get the article and reads all this to you. So this is, a lot of all this stuff is already covered on the website. Just people don't read, so I figured I'd make a video of it. How to calculate your performance unit, or how to even calculate the BTUs of heat on your truck mount, is all on the website. So the interesting thing about your performance unit number, once you have that, or if you're looking at like, hey, I want to buy a package, right? I'm looking at this piece of equipment. What is the performance unit number, and how much does it cost? I can actually divide my money into my performance unit, and I come up with a number. How much did it cost per performance unit, right? If I'm looking at package A and package B, and naturally the performance unit numbers will be slightly different, but the price will be different. Well, maybe one's more value than the other. So you can actually divide your cost into your performance unit to come up with your cost per performance unit. And that's a real easy way to help kind of break down your cleaning. One other thing I noticed I forgot to mention. So one time I had a customer said, hey, we got a bunch of kitty litter that's all over the carpet. And I was thinking, well, what's the pH of kitty litter? So you can buy litmus paper at a swimming pool supply, and you can have distilled water with you. And if you put a little bit of distilled water on the contamination in the carpet, and then put litmus paper into that water, and you can get a pH reading to find out what the contaminant is. Turns out that kitty litter has a high pH, and in order to clean it, you have to use an acid. So we do sell acid side chemicals. This is an example. Flush Out, which is a urine contamination rinsing product, cleaning and rinsing product. And why is that? Because, you know, urine comes out of the body as an acid, but when it gets old, the hydrogen and oxygen evaporate out of it, and it starts to smell like ammonia. Well, ammonia actually has a pH of about 12. It's way up here. And in order to get old urine out of carpet, you have to use a acid side cleaner like Flush Out or Pro's Choice UPT Plus. There's a whole bunch on the market, which allows you to pre-spray down here in the acid side because you're removing old alkaline contaminants. So that's a little bit clarification of the pH, and what you're trying to do is do the opposite of your contaminants. And another thing, I was going to put my email up here. I don't think you can comment on our channel. We've had 20 years of people writing negative, derogatory stuff about our company, and so all those comment options have been removed. And I don't even know, you know, mostly it's competitors, I assume, that were doing that. But anyway, if you have a question, you have to email us at info@steambright.com, because I don't think you can comment on YouTube. But anyway, thank you very much for watching, and if you have any more ideas or classes you want me to cover, I'll be glad to do that.